Okay, so in this video, we want to quickly review two basic properties of roots and also conclude with a word of caution. So if you have, say, the nth root of a product of terms, so nth root of xy, then you can apply the nth root onto each individual term. So this is also the nth root of x times the nth root of y. So you can always distribute a root over a product by taking the root of each individual term. The same is true for a quotient. So if you had, say, the nth root of x over y, this is the same as the nth root of x over the nth root of y. And if you think about this, well, we've already verified these two properties when we look at exponents. But a root is also an exponent, right? The nth root is an exponent of 1 to the n. So this is essentially redundant. Taking an exponent onto a product, we can always distribute the exponent onto each individual term. X to the 1 over n, y to the 1 over n. And again, a power of 1 over n is the same as the nth root. And of course, the same goes for the quotient. So x over y to the 1 over n is the same as the nth root of x over y. We can apply the exponent onto each individual term of our quotient, so therefore x to the 1 over n over y to the 1 over n. And again, a power of 1 over n is the nth root of x, nth root of y. So two basic properties of roots. Simply put, any root can be distributed onto a product or a quotient of terms. What is not true, on the other hand, is that a root can be distributed over a sum or difference of terms. So in general, if you say the nth root of a sum of terms, the same goes for a difference. This is not the same as the nth root of x plus the nth root of y. In general, and again, if n is different than 1. As if n is 1, then clearly we get here simply x plus y, and again here x plus y. So the result, both sides are equal. But as long as n is not equal to 1, these are not equal in general. And again, we can easily give a counterexample for this by picking, say, two positive values for x and y, and a positive value for n. We'll all pick integers, and we'll give two separate counterexamples. Let's pick n to be 2. So if n is 2, what we have is the familiar square root. So let's first pick both x and y to be equal to 1. So let's call this the left-hand side, and this the right-hand side. So if n is 2, again we have the square root, and if x and y are both 1, then on the left we have the root of 1 plus 1, which is the root of 2, which you should know is an irrational number, which means it cannot be expressed as the quotient of two integers. What about the right-hand side, if n is 2 and x and y are both 1? Then we have the square root of 1 plus the square root of 1. But the square root of 1 is 1, so what we have is 1 plus 1, which is 2, which clearly is not the same as the square root of 2. So the right-hand side is clearly different from the left-hand side. We can give another example. Let's now pick again n to be 2. So we have once again the familiar square root. Let's pick x to be 16 and y to be 9. This will provide an even nicer counterexample, and you'll see why in a second. So then we have the left-hand side is the square root of, and again 16 plus 9 will be, well, 16 plus 9 is 25, so root of 25, which is of course 5, as 5 squared is 25. What about the right-hand side? Then we have the square root of 16 plus square root of 9. If we try to apply the square root onto the two terms of our sum, well, the root of 16 is 4, as 4 squared is 16, plus the root of 9 is 3, as 3 squared is 9, and 4 plus 3 is 7. Clearly not equal to 5, and so once again the right-hand side is not equal to the left-hand side. So to summarize, if you ever have a root applied to a product or a quotient, you can distribute the root onto each individual term of the product or the quotient, but the same property does not apply over a sum and, as I've said before, difference of terms. So always be very careful not to make up rules that are not true. And if you are ever in doubt whether you're about to make up a rule that is not true, well, test it with a few examples, and you will see whether the rule seems legitimate or clearly is not true. And that's it.